Good afternoon or good morning, everyone, depending on where you're tuning in from. Welcome to our final stop on our virtual road trip of 2020. I'm Molly Soltis with Asphalt Testing Solutions and Engineering, and it's my pleasure to welcome you on board today as we travel to the Louisiana Bayou. We're joined by two industry experts who will share their perspectives of using the balanced mix design process for approval from both a contractor's and owner's point of view. Before I introduce them, let's go over a few housekeeping items. The attendee controls appear at the bottom of your screen. In the bottom left-hand corner, you'll find the audio settings. Since you're a webinar attendee, you will be in listen-only mode. But later in the webinar, if you would like to join the conversation, you can use the raise hand icon, and time permitting, we'll unmute you so you can address our presenters. If you have a question, but you prefer to stay muted, please use the Q&A window. Open this window and type in your question. Now I'd like to introduce today's speakers. Tim Webster is the Performance Lab Manager here at ATS. He has over 15 years experience in the industry, 13 of those with the Florida Department of Transportation, working in materials testing. Dr. Sam Cooper is the Materials Research Administrator for the Louisiana Department of Transportation and Development and an Assistant Research Professor at LSU. Prior to his current role, he was the Asphalt Research Lab Manager for the Louisiana Department of Transportation and Development, and he has been involved with the implementation of balanced mix design in Louisiana from the beginning. Barry Nunez has over 40 years experience in the asphalt industry, focusing on lab management, training, and supervision. After years in QC manager positions, Barry started his consulting business, and he also works for Infratest USA and Asphalt Wax and Innovations. So as we prepare to depart, I'd like to thank you for choosing ATS as your preferred travel provider today. And please take a moment to locate your nearest exit. Remember, in some cases it may be behind you, but most of you can locate yours in the bottom right-hand corner of your screen. Enjoy your trip.
Good afternoon, everybody. I'm assuming you can hear me. I can't see myself, so I'm just going to jump right in. My name is Sam Cooper. I'm the Materials Research Administrator, as Molly had said, for the Louisiana Department of Transportation and Development. And what I'm going to talk about today is the development and background and how we got into the balanced mix design process that we use at Louisiana Department of Transportation, and kind of some observations we've found throughout the implementation process, and maybe touch on some things that worked well and some things that we had to make a couple revisions on. So hopefully we can discuss that after the presentation as well. So in general, the process of what we did for the Department of Transportation, we've been implemented now for about 4 years. Since 2016 was when our first balanced mix design, if we'll call it that, was implemented. And that really came after a long time of development and evaluating mixtures for laboratory performance, if you will, and correlating that to field performance. So a lot of people were involved in this process, namely LTRC's research, asphalt research group, our department materials lab, MCREF, which is the LSU research facility here at LTRC, and the HMA producers in Louisiana were vital to getting us to where we are today. We went through pilot specifications, we did field trials, we made practical adjustments because everything we do here in the lab or on the agency side of things doesn't always translate to real world situations where the contractors would be comfortable using everything that we think up over here in the labs. And with those practical adjustments came industry buy-in into the system. So when the industry is able to see the types of benefits that can be achieved through implementing laboratory testing, it makes it much easier to get into the whole situation and get it implemented. And then last but not least was training. Training was one of the more important aspects of the whole process. Okay, so why did we think we needed to get there? As most states go, the Louisiana's DOTD's conventional design practice was to use volumetrics as design. And those volumetrics, as we increase the amount of recycled content, we're not doing a good job in picking up potential issues, whether it was compatibility issues or an aging issue or an oxidation issue in our field performance. We got really good at making sure our mixtures didn't rut, but in that process, we ended up with mixtures that were subject to premature cracking. So all of that came down to is volumetrics are good at determining the quantity of materials, the quantity of the asphalt in our mixture, but not necessarily good at identifying the quality of the asphalt binder that's going into our mixture. And so how can we determine the quality of the binders that are being used in our mixtures? And the most common way, and probably the most straightforward way, is to do laboratory testing to determine or characterize the properties of the materials going into the mixture, and then the mixture once everything's combined. And so initially what we were looking for is screening tests that would be able to screen out materials that would be prone to rutting, cracking, or moisture damage. And in this process, when we were doing all this research, it really lended itself to being a balanced mixture design. So we leaned on the volumetrics still, as most agencies will tend to do, because it's what we've been using for so long, and for a majority of the time gave us good performance. But understanding that a transition needs to occur as we want to be more sustainable and increase our recycled content, that we may need other indicators to give us the performance we're looking for. So by definition, balanced mixture design in Louisiana is a combination of cracking performance, rutting performance, and volumetric properties. And I think the formal definition, and where most states are trying to get to, is where we would just use these cracking and rutting tests to evaluate the mixture, and then the volumetrics would eventually kind of become a lesser role in the pavement design or in the mixture design itself. But of course, until we get to the point where we have that, I guess that database and that comfort level, I'm sure most states will continue to use volumetric properties as a fallback, if you will. And essentially what we do is we run a cracking test, we run a rutting test, and we make sure our mixtures fall into a quadrant that is going to give us both good rutting resistance and good cracking resistance. So in terms of our selection criteria, what we were looking for, we wanted a mechanistic test, a test that could be used to in our pavement design as well, because if we're going to be running laboratory testing and collecting the data, we'd like to be able to use it in more than one way. So if it's a mechanistic test or a fundamental test, then we're able to use that in pavement design to help determine our asphalt layer thickness values. And particularly in Louisiana, we were interested in intermediate temperature cracking to give us fatigue endurance. We do not have a lot of thermal cracking here in Louisiana, so it's not a very large concern. And even our fatigue cracking is on the higher temperature end of the fatigue cracking spectrum. Our high temperature, of course, we are concerned with permanent deformation. And again, our conventional mixtures over the last several years has really not been, permanent deformation has not been an issue. So the features we were looking for, something fundamental, something easy to use, something reliable and repeatable, and something that is not going to drive the cost up. You know, if we're going to rely on our contractors who conduct our mixture designs to run these tests, it can't require a $250,000 piece of equipment. So rutting resistance was pretty straightforward. We used the Hamburg loaded wheel tracking test. We've used it for a very long time here at DOT. So the comfort level was high. We actually had implemented this first in terms of a introduction into laboratory testing for our contractors. And this really I guess, gave a sense of it eased the tension, I guess, in terms of having to get into laboratory testing as far as moving from volumetrics only. And then cracking tests, the big question is which test to use. And in Louisiana, we used the intermediate temperature semicircular bend test for a very long time, since 2002, I think, was when the test was developed. And most of it was conducted for research purposes and forensics purposes. So we had a very, you know, a high comfort level with this test and being able to run it. But we did look at other tests, and we constantly look at other tests as a research facility. A lot of our research projects employ the uses of these of all these different cracking tests, and each one has advantages and disadvantages. It's really a matter of what the comfort level in the state and the types of cracking you're interested in. Top-down cracking has a different mechanism than bottom-up cracking or low temperature cracking. So it's really, you have to look and see what type of cracking you have in your state, and then evaluate these test procedures and figure out which one gives you the most logical responses. If you have a lot of recycled content, then you would expect to see a reduced cracking resistance. If you have higher density, you expect to see reduced cracking resistance. Those types of things have to logically make sense for you and your agency in terms of which cracking tests to evaluate. So Louisiana DOT, with the comfort level and the correlation we saw to our field performance, we selected the ASTM 8044, which is the intermediate temperature semicircular bend test. And so the reasons we did it, we could use a gyratory pill to make the specimens. We could adapt the testing equipment to a plant lab versus just our research grade equipment. And again, I can't stress enough the history of forensic success and field correlation to the test parameter we were evaluating. Okay, and we did a lot of work to get into variability and making sure the test specimens are prepared in a way that we can get good repeatability and get that confidence up. This is just an example of all the different retrofits we did. All these pieces of equipment are at LTRC, but we started with research grade and then we moved on to more lab type setups and other research grade setups. So I guess at the same time as implementing these two tests, we also did some volumetric changes to our specification. We lowered the gyrations from near 100 gyrations down to 55 and 65. Our air void content has always been 3.5% for at least the last three specifications. We raised the VFA from a minimum of 68 to 72, and we raised the VMA of 0.5%. And as we did that, we started collecting data and getting into evaluating what our prior mixtures, so prior to the 2016 specification, what they look like if we were to plot them in that space diagram that we showed earlier. And then we had some stars here. These stars represent pilot mixtures. So the pilot mixtures were produced using the balanced mix design, but without really making, major changes to the mix. It was kind of we have this job, we want to start evaluating what happens when we lower gyrations and things like that. Okay. The criteria that we selected for our mix design was based on our field validation. It's based on traffic inputs and traffic triggers on when a rehabilitation is required for a roadway. And different levels of traffic require different trigger values. And based on this, we were able to determine from our cracking index where our laboratory measured SCB result would be. Okay, so we landed on values of around 0.48 and 0.6 for where our triggers would occur based on the projects we looked at, and that resulted in our current 5027 table, which is our asphalt mix design table, which has, again, for our different levels of traffic, the minimum cracking test criteria, and realizing that we have lower traffic levels for LWT, or varying traffic levels for LWT testing, we varied those as well. So prior to this spec, all of our mixtures, regardless of traffic, were 6 millimeters at 20,000 passes. But realizing that with the increased asphalt content we may be seeing, plus this is an extremely rigid rut depth of 6 millimeters, that we could afford a little bit more for our level 1 or our low traffic level mixtures. So in Louisiana, we developed a system to conduct the mechanical property testing based on the performance or anticipated performance of asphalt mixtures. And again, that's based on laboratory test development and correlating that to field results. And that's really where an agency has to be confident in their data and reviewing it and their performance data as well. And LWT and SCB were the most feasible for implementation in Louisiana by both the state and the contractors in the state. And then we incorporated these tests into the specification compliance evaluation. Now, in 2015, the year prior to the spec going live, we held a training workshop to train everybody. And the participants in this training workshop were contractors, Louisiana DOT district personnel, as well as consultants. And the real thing here was our contractors and districts at this point were fairly confident with mechanical testing. They had been running LWTs. LWTs are very user-friendly in comparison to a cracking test, really any of the cracking tests. So we really wanted to spend a full day going through the history and the concept and how to make specimens. And we made a video and we brought everybody to the labs and we showed everybody our process and everything. And that really helped people get more comfortable with running this test, because, you know, me from a research lab, I ran this test, you know, I can't even count how many times. You know, I've ran it for years. But throwing it out there to the contractors who, you know, didn't have to cut notches in specimens, didn't have to cut specimens in half, didn't have to compact specimens to height meeting a specific density. All those things were new, and that was understood, and we wanted to be helpful rather than be a roadblock into that situation. So we developed protocols to be used on Marshall load frames, the lab type equipment. And then the contractors since then, I mean, we're 4 years in now, they bought in and got the equipment required and started cutting the specimens and running the test. And we're seeing reports of the fracture energy, which is the tested value that comes out of the SCB, variability less than 15%, which is generally pretty good for asphalt mixtures. Specimen fabrication is always the hardest part. That's going to lead to the most variability when we do it. And I think the biggest complaint, and one we've heard for a while, and we're still in the process of, is figuring out how to get rid of that 5-day 85C, but still make sure our test is determining the fracture resistance of the asphalt in its most embrittled state, which is its highly oxidized state. Influence on the mixtures, we've seen we have seen a slight increase in the Hamburg rut depth, but I say that understanding that we were seeing mixtures produced with PG76 -22 with a 2 millimeter rut. Now those mixtures at a 4 millimeter rut. So it's not really a bad type of increase, but there is a little bit of an increase. There's still less than the specified limits. The SCB parameter is being met, consistently being met. I've seen very few failures in the submitted JMFs. And the asphalt content has increased. It was ranging from about 0.2 to 0.4. It's now settled down to around a 0.3% increase in asphalt content. The VFA is no longer at the bottom of the range. Again, the range used to be 68, and pretty much most of our JMFs were around that 68 to 70 range. Now they're sitting around, with the new limit of 72, they're sitting around the 74 range. So they're no longer just sitting at the bottom of our specified range. And the pilot mixtures are performing to date. Again, it's only been 5 years now, 6 years now since the pilots went down, but I have not seen any premature cracking. So one of the things we really like about this is we are a state that allows plant blending. And so we're finding out a lot about the relationship between base binders and the different components that we mix into them. And what the LWT and the SCB are both capable of doing is screening out binder blend compatibility issues. And those mainly showed up between crumb rubber and latex blends that we do at our plant facilities. And through running these tests, we're able to say, okay, this base binder is not working, or something needs to be added to this base binder to get this plant blend in place. There were a few failures at the beginning of implementation, of course, but most of those were just simply tweaks to the mixture design. They're not complete overhauls in terms of everything in the mixture design. Sometimes it's a binder that's not compatible. Sometimes it's a little bit too much dust or fine aggregate in the mix. I'm sure Barry's going to touch on a lot of the mix characteristics that he was able to tweak in order to meet the JC. But really, for the most part, once the contractors were made aware of the upcoming changes, they were able to kind of get everything in order, get their ideas on paper, and start tweaking their mixtures prior to actually being held to the specification. Another thing we like about it is it allows innovation, both on the contractor and the state side. We allow binder substitutions for lower traffic roads as long as the LWT and the SCB criteria are met. Because again, at the end of the day, what we're looking for is a mixture that's going to not rut, not crack, be skid resistant, etc. It doesn't necessarily matter in the grand scheme of things what goes in it, as long as it performs in those key areas and lasts, for 20 plus years. That's what we all hope. So having these tests allows for contractors to be innovative and being able to achieve those criteria and still be able to put this mixture down on the roadway. So we're currently in the process of doing research to monitor all of our roadways produced, or our mixtures produced with the new balanced mix design spec. It's again only four years since full implementation, 5.5 or so since our pilots went down, and I haven't received any premature cracking or rutting failures to date. But we drive these roads every 6 months or so and get performance data, and that's part of an ongoing research project. So we'll continue to collect this information, conducting the research. We're looking into right now creating a QC protocol for SCB testing, but it would not be the full 8044 test that we've implemented for design. It would be a different protocol. And of course, the accelerated aging protocol, in order to be able to speed up these designs faster so they don't take a week to do. I provided a link here. I know it's, y'all probably can't click it, but this is the location of our supplemental specification for the 2016 supplemental spec. It's only the part 5 of the spec book, but it is the entire part 5 of the spec book is our supplemental. And that was done in 8/18 was our most recent revision to it. So, and with that, that's my last slide. I know this is, there may be a few people from the University of Florida here. I think I see a shoe down here on the left side. Maybe that was thrown all the way from Gainesville, because this picture was taken on LSU's campus. So I'm not sure where that shoe came from, but it looks like it traveled quite a distance. And with that, I will allow, I guess, Molly to take over or Barry to take over and talk about the contractor perspective.
All right, well, good afternoon. Thanks, Sam. Sam and I have worked together off and on for projects through the years, and it's always been a good experience. I've worked with his predecessors, and I'm so late in my career, I have a feeling I won't be working with anyone after Sam. So let me get started here, and we'll talk about what I ran into when I first got into this. Okay, so we're talking about balanced asphalt mix design, but I wanted to bring up a point that with Louisiana holding on to the volumetrics, I've learned recently that it's technically called a performance engineered design. We have the 3.5% air voids that we've been using for a while, which does help us get a little bit more asphalt in the mixtures to begin with. And Sam went over some of those spec changes, and I'll have some slides that he had given to me, and I'll breeze through them fairly quickly and get on to the meat of what I'm going to talk about. I formerly was a QC manager at Diamond B Construction, and as they said, I started my own consulting business back in 2017. So before we get into this, when I gave a similar presentation at TRB a couple of years ago, I wanted to subtitle it Full Circle, the history of mix design. And if you've been around it as long as me, or you've done a lot of FAA work, most people are at least familiar with Marshall mix designs, but that's what I grew up in, is Marshall mix designs. And if you get right down to it, the Marshall mix design kind of was the first balanced mix design, because we averaged the voids, the stability curve, and the VFA or the VMA to arrive at an optimum asphalt content. And Super Pave needed this. It started off very dry and very harsh gradations. And yeah, we fixed all the rutting in the nation, and we ended up with rattling. So I love the direction we're going in with the balanced mix design. Louisiana specifications were coming for a while. We were like, when's it going to happen? They finally implemented it. How's it going to affect our modified liquid asphalts? I was with a company that was doing latex and chrome rubber. And then we had the change coming where we could increase our wrap 5% on wearings from 15 to 20, and from 20 to 25 in binder courses. And will we be able to do that? Will the LWT still pass? How much is that aged asphalt going to affect this? And after attending a few conferences through the years, when they first started talking about balanced mix design, everybody said, well, you're going to have to throw 0.5% more liquid in it. Well, from a contractor's point of view, that's a lot of liquid and a lot of cost. And so as a designer, I'm always trying to design a very high quality mix at the lowest cost possible. And that's why, as Sam referenced, we often were in the bottom sections of the VFA, and just enough to meet the VMA requirements. So I think this pushes us in a direction that we all have to do it, so it's an even playing field for everybody at the bid table. So you've seen this slide from Sammy, and yeah, we're looking to find the perfect spot in volumetrics that gives us cracking and high temperature performance on the wheel rutting test, and able to meet the cracking and everything else. So these are a few slides which just kind of shows the samples. We cut them in half. We make them 60 millimeters here. Originally it was 57 millimeters. They allowed us to use the 60 because it matches what we make all the time for our LWT or Hamburgs. And so we're now doing the test mostly at 60 millimeters. And you can see how the breaking head works and separates that sample to do the propagation on the tearing of that sample. Yes, we do it at ambient temperature, 25 degrees C. These are just some curves that kind of show you what they look like once you get them into the program and you get all that data laid out. It's kind of beyond me, but luckily Sam has provided us with a nifty spreadsheet that spits it all out at the end and tells us what our JC actually turned out to be. This is some more slides on looking at some of the curves and the fixtures being used. And you know, once again, Sam reviewed this. I won't go too in deeply. We did drop our gyrations. We held on to 3.5% air voids, where other states, where they're really truly doing a balanced mix design, start at 4, or they just do the rutting and cracking test and find the most optimum number of, you know, for the asphalt content, optimum asphalt content using those parameters. And if they do look at 4% air voids and have volumetric requirements, then let's just say your balanced mix design moves you to a 3.6% air void or a 3.7% air void, well, then they'll give you plus or minus 1% off of that. So in Louisiana, we're already at 3.5. We've held on to that. They raised the VFA. I think that helped us quite a bit because we've had a lot of mixes that really met this spec. And I'll go ahead and say it here. The study that I'm going to show you here was my experience using a crushed gravel, just a river gravel that is crushed or a crusher with some coarse sand and a blended sand, which I think had a lot to do with why my first one in that arena failed. All the limestone mixes that I've worked with over the last 5 years in doing this, I've never seen one fail. And I've never seen any major problems in LWTs as well. The Hamburg, the rut depths are still very good, as Sam indicated. These are some more of the specs. Sam reviewed these. I'm not going to review them again. Once again, though, when we did get to increase the wrap, we did have to fractionate. At least, we didn't have to fractionate real fine. We had to at least take off the top 1 inch. And that was a good move. And we finally got the state to agree that we didn't have to do this ahead of the time. We could put a 1 inch scalping scream on our wrap in direct line on the plant. So I'm going to jump right into my result. The results minimum for a level 1 was a 0.45. Well, 0.5 technically. So you need a 4.5 or above to make that 0.5. And my first one failed. It was a 0.36. So, you know, you're standing there, you're in the lab. I had a technician, Junius Howard, working with me. And we looked at this and we're like, oh goodness, oh my goodness, what do we do? So we tried to call Sam Cooper, no answer. We called Dr. Luay Muhammad, got a hold of him. He says, yes, you're probably going to need a 0.5% more asphalt, but maybe you should look at your design and see what you could do to manipulate it. What could you change? So I went back to Sam. We talked to him. And once again, he said, well, maybe the 0.5 is not really needed. Once again, he said, look at your structures, look at your mix, see what you think you can do to improve it. Now, he didn't give me a flat answer. So we start reasoning and we start thinking and we start theorizing. And then all of a sudden we had the light bulb moment. We thought about it and we said, okay, so it's not necessarily about a total more asphalt. Maybe it's really about more film thickness. Maybe we don't have a spec on film thickness. Maybe it's at least not in dense graded mixes, only in an OGFC, open graded. So it's actually about more free asphalt, maybe. You know, maybe about the asphalt that's not absorbed, the asphalt that's available to perform outside of the aggregate. So we start thinking about it and we say, well, maybe we can cut back on the fines just a little bit. Maybe that'll improve it. Let's see what a little bit will do. Or maybe just adding a touch more large aggregate or a touch more intermediate aggregates like a number 89 or an 8. And let's restructure the gradation of the mixture just a tad and let's try it. And so we did. And so what you're seeing here is the cold feed percentages that I started off with and the cold feed percentages that I ended up with. And there was one test run in between, which I'll talk about in a second, that only had a 1% change on the blend. So we went to 13, and in the end, we went down to 12. We did manipulate the top in the first go round, dropped it 1% here, and kept this the same and added 1% on a quarter by 0. which is similar to your 8s or 89s, that it is a crushed gravel and very angular. And so we always get LWTs that pass really well with that. So here's my final gradation. You can see that there's not a lot of change. 98 on the 3/4, 85, 84 on the half, from 76 to 75 on the 3/8, 52 to 51 on the 4. The 8 screen only changed 1%, 39 to 38, 29 to 28, 23 to 22, 15 to 14. 8 and 8 on the 200. The point that we did in between was at a 5.6. That was our first attempt. And when we did that, we were like, well, we need to check the volumetrics. Let's see what it looks like. Our original design called for a 4.8. So will we stay at a 4.8 or will it be a 4.9? And when we made those changes, this is what we found. I want to bring up this. I forgot about this in the slide. So Louisiana has a ductility spec and some states have dropped it. But I think this proves a real need for it in your liquid asphalts. We happen to have some ductility, some liquid asphalt that did not pass Louisiana's ductility spec. And after talking to Dr. Luwe and Sam, we said, you know what, let's make a set of SCBs on that, just, you know, with the original design and compare that. Well, you can see it's extremely low, a 0.19. Our first failure was a 0.36. And then when we made the first 1% change, we got to 0.47. Now that technically passes, it rounds to a 0.5. But because this was our first one, and I didn't want to be marginal, I said, let's go that 1% more and let's see what it does. And let's see what else it changes. Well, cutting the dust, that 1% more jumped us all the way up to a 0.6, which is quite an increase. We're very happy with that. And after I got through with the volumetrics, I only added 1 more tenth asphalt to get that 0.6, because it showed that it needed it to maintain the 3.5% air voids. And so the combination of 0.6 of dust, slight manipulation on the rest of the aggregates, and 1/10 of asphalt, we met the spec by leaps and bounds. So the simple key, free asphalt as opposed to absorbed asphalt, is a very big key here to make an SCB that's borderline or failing to move it up the ladder. So it doesn't always have to be a 0.5% more asphalt. Now, I understand if you got a mixed design and you're doing this in other states, that you know, you might just take that mixed design and run the 2 tests, and if it shows 0.3 more or 0.4 more or 0.5 more, maybe that's what the state wants you to do. But as most contractors, we're in a low bid world, so we got to be true designers, manipulate those gradations, work with that dust, and I think you'll get some very good results without increasing the mixed cost a lot. So what I'm saying is study every aspect, the gradation structure, the asphalt type and quality. I have seen passing SCBs on anything from a PG67 to our PG70 SBS, PG70 latex, SBS PG76, and chrome rubber modified. And we no longer make the 82 that Sam referred to. We now have to meet a 76 with chrome rubber, but we still have to meet the MSCR. And we found ways to meet that as well. And they're all working good in this state now. So I think we're getting better mixed designs. The effective asphalt content is really a key. The aged and unaged asphalt combinations are worth looking at. Look at your VMA. Don't try to be too borderline with that, and get that BFA off the bottom. So do the work and do not settle. And not being a guy who's got a degree, when I got through, I felt like I graduated. So that's the end of my presentation, and we will now be ready for our questions.
All right, so we want to thank both Sam and Barry for those presentations. And if you have questions, go ahead and hit us up and we'll read those out. And if you want to talk to them one-on-one, let me know and I will be sure to set you up that way as well. We have a question in there right now, so let me go ahead and see what it says, and here we go. All right. I know Sung-Ho Kim had been asking some questions, and Barry had been, or Sam had been answering them. So his next question was, how are you going to make sure with binder source issues, then since all the contractors can't go through checking binders whenever they have testing failures? I believe the issued binder also passed your binder requirement, PG. Then he says, or right. I mean, I know you guys have been, he's been talking with somebody already. So do you want to go ahead and carry on with some more answers with that?
Yeah, I can elaborate a little bit more on it. So this question was in response to the compatibility issues that we had noticed in a couple of our plant blending operations. This typically is not an issue with SBS modified. The compatibility and everything is checked and ensured by the terminal. You know, so that makes it a little bit easier. But the when we add chrome rubber and we add latex, occasionally there can be some compatibility issues where it just one base binder may be working for a time, and a new shipment comes in, and I'm sure Barry could elaborate on this way more than I can because he actually had to do it. But you use the chrome rubber, the same package and everything, and it just doesn't work on the next terminal shipment that you get. I know some additional modifiers were used to get it to work at times. Sometimes a switch in base binder is used. And yes, these binders meet our PG requirements, our PG plus requirements. And occasionally it's just something in the formulation has changed from the terminal, and it just doesn't work. So these tests that we've implemented, they showed it. So what happens is a couple of times our LWTs didn't make it 5,000 passes, and on a mix that always would go 20,000 passes and show 3 millimeters of rut, it would disintegrate essentially in the first 5,000 or first 10,000 passes. Well, that shows something is wrong. And then SCBs, we run them. Typically, we see modified binders have a higher JC value than an unmodified binder. What will happen if there's a compatibility issue is the SCB result will be more similar to an unmodified binder, a very low JC value, less than 0.4 or so. And so when those things pop up, it gets to a point where we have to start investigating the materials that go into it. And our contractors in this state do a very good job of troubleshooting their materials when something doesn't look right. It says they don't go through checking the binders. Our contractors do check their binders. They'll start running DSRs. They'll start running RVs and see, what doesn't look right from what they produced or what they had received before to what they received in the last shipment. They also go through all the information provided by the terminal on the COA, the certificate they receive. So,
what you were talking about, Sam, you're right. I've had to worry about keeping latex formulas and asphalt, chrome rubber formulas working like the original. And the streams from the terminals, they do sometimes change. Now, I've never run any SCBs on a liquid that changed, but we don't keep running with that liquid if we know that we got a problem. We have to reformulate and make sure that we've got the liquid meeting the spec entirely. So you're saying that at the LTRC, y'all have gotten data on streams that have changed and see a passing results just simply fail after that?
Yeah. Just from working with, I can think of a couple OGFC specimens and a couple SMA type specimens that that we were seeing issues with. It's not a really common issue, especially in our dense mixtures. But when we start to get to the more coarse aggregate, high film thickness mixtures, you start to see those compatibility issues pop up.
Gotcha.
Still rare, but it does occur.
So yeah, when you're self-modifying as a contractor, and I've worked for a contractor who did quite a bit of that, that is a job, that is a full-time job, monitoring that liquid and monitoring, and we are required by spec to test it daily. And so we identify it pretty early if there's a change, at least with the DSR. We don't run the full set of asphalt testing that you would run on it, but you know, all your binder liquid testing, but we do run a DSR that tells it a lot real quick. And of course, we immediately take action and do something about it right away, because you can't produce mix out of spec, you know, with a liquid that doesn't meet the spec. So, you know, contractors who want to self-modify, there's definitely some savings to be had, but it is a full-time job, and you have to stay on top of it because asphalt streams change all the time. And you know, you could have one. I've had one before that just was consistent for maybe 2 years, and all of a sudden it changed, and you had to change something. I've had other suppliers that it seemed like it changed every 3 to 4 months. And so, yeah, that is a good question. And it is something we have to monitor if we're doing self-modification. However, if you are buying from a terminal with SBS, you don't deal with that at all.
Good, thanks guys. Next question, it says, Barry, sounds like small changes in gradation make MD pass from fail, performance testing sensitivity. Then I'm wondering if you can really maintain production variation with that type of sensitivity.
That's a very good question. I don't have any data. Now, I know the LTRC with Sam have went out to jobs and taken some samples. I don't know if you've got any on our gravel mixes out there. I'm sure you probably have. But once we pass that and we submit that, it's a bona fide mix design, and we go out there and produce it every day. We're not required to do more testing on the SCB during production. And maybe I should be ashamed to say, but we didn't do it. You know, sometimes the contractor is only motivated by what he has to do, just being honest. And maybe he's scared to find out, but you're right. Minor changes can make a difference. So it could become obvious that minor changes in production could have a serious change on what you're producing. But that's why another reason I didn't settle for a 0.45 or a 0.47. I went the extra step. I actually met the spec of the level 2 mix, which is a 0.6. And so I had a much stronger level of confidence with that. And that's why, as a QC manager, I chose that.
Yeah, and I can add a little to that. Yeah. Certainly, we understand that there is production variation, and we're currently collecting mixtures, you know, still 5 years after this implementation, to quantify that. We know there's differences between lab-produced material and plant-produced material, regardless of the parameter you're measuring. And so establishing some relationship between our design criteria and the plant-produced criteria is something we're working on. And where we selected the limits is crucial to that. Where, you know, I showed where we our trigger value for low volume roadways was a little less than 0.5, and we established our value to be at 0.5. And so there was some confidence or some factor of safety built in there. Also understanding that as we implemented this, our mixtures that we were getting of JCs of 0.35, 0.4 were likely to be no longer being designed. Then that variation, if they drop a little bit, they'll still be greater than, you know, if our new mixtures drop a little bit, they'll still be greater than what we were getting from the initial design. So if someone, if a contractor was producing a mixture that's JC at design was 0.35 and a variation occurred, now some of that mixture coming out of the plant is actually at a 0.2 or a 0.25, you know, that's a problem. If we establish that limit to a 0.5 and the variation occurs, and now that results in a JC of 0.45, that's much better than a 0.25. So we understand that there could be some impact to that, and that's part of our research that's ongoing right now to implement a SCB protocol for QC.
In production.
Yes, during production for QC.
So
Yeah,
my 0.36, I'm sorry, my 0.36, if I hit that in production, that wasn't too bad?
I would prefer not to have been hit, but that's why your designs were 0.6. So you
That's
know
right.
that,
A good QC manager will make that choice.
All right, on top of that question, and you guys kind of answered it right then. So it's
Okay.
like still use old requirements, AC gradation or volumetrics, et cetera, for acceptance and payment. And then it says, but do you plan on running production testing for acceptance at some point? Is that in the work?
I think that's ultimately where we want to go. We understand there has to be modifications to the procedures in order to be able to run that test and not have to wait a week to find out your results.
Right.
You know, it's like to be able to get pay results under, you know, as fast as possible. We do have a LWT requirement that's done during production. Contractor pulls a specimen and runs an LWT. They have not run an SCB yet during production in the specification outside of our research. Our current pay parameters are density on the roadway and smoothness on the roadway. So we don't pay for gradation, we don't pay for AC, we don't pay for volumetrics.
And they don't pay bonuses anymore either.
And we don't pay bonuses anymore either.
Except for ride, and is that it? Ride?
Just smoothness on
Yeah. We either pass on compaction. The good old days of getting those nice bonuses have dipped way down, but we can still get a ride bonus, and we got to meet density. So they're getting some quality out there.
And question here, what would you estimate your state's contractors spent on average to implement BMD, balanced mix design?
I can only speak for the equipment cost. I'm not sure what what personnel cost and things like that would have gone into it, but the purchasing of a saw to cut the specimens, the purchasing of maybe an additional oven, and potentially upgrading their Marshall frames, because a lot of our parishes here, or counties for people that aren't in Louisiana, use Marshall design still. So they still had the load frames that we retrofit, or that we did the research to retrofit onto. So if they had to buy a new load frame, that's what, $6,000 or so. If they had to buy a new saw, $1,500.
Maybe 3,000.
Yeah. So depending on the saw you buy.
Right.
So $10,000 is probably the high estimate, I would think.
Yeah.
With the equipment, probably as low as 7,500. In that range is probably more typical range.
Okay. Question from Tim Carter. You mentioned modified binders of latex and crumb rubber. Do you have any data on SBS polymer modified binder mixes?
Yeah, and the majority of our evaluation was SBS modified, almost all of it. The only reason I mentioned the latex and the rubber was that's where we saw some compatibility issues or failures that we could associate with compatibility. I'm not saying the rubber mixtures and latex mixtures don't perform in these tests, because we've seen 90% of the cases they do, and those 10% of the cases we've attributed to either not getting enough of the asphalt in there because of the reduction in asphalt that you get when you use say a rubber at up to 10%, or a compatibility issue between the rubber and the asphalt, the base asphalt.
I've read a lot of them, and once I got going on this thing, I didn't have any failures with latex or crumb rubber. Once I got going, I was very fortunate in that area. We did it all the time, and we'd pass with those materials as well.
For Barry, also wondering about any unit price increase with BMD design comparing to traditional mix design.
Well, that's a good question, and at the end of the day, we got to go to the bid table, and it's an even playing field. Sammy says he's seen about a 0.3 increase in asphalt contents from where they used to be. A lot of my mix designs are only about a 1/10 or 2, and I'm meeting the specs. Maybe I'm just very cost conscious, but I'm able to meet the spec, and you know, whatever your state is, 50 cents a 1/10 will be about your average mix cost. So you're talking, you know, 50 cents to $1.50 increase in mix cost.
I know with a lot of the tests that we've ran, you know, we're like you guys were saying, the 0.5% AC will make everything better. But again, if you're not playing with, you know, if you're not messing with the gradation and all things like that, well, yeah, that's the simple answer. But I mean, you guys have shown today and proved today that those other issues can fix things as well.
Absolutely.
Another question: did you use your BMD stuff on the interstates? And I'm assuming you did.
Yeah, our current specification, any travel lane, binder, or wearing course mixture has to go through SCB and LWT testing.
I know a question I was going to ask was, you know, in Florida, you have your contractor or whatever that say, well, we don't have a rutting problem here. Our roads take a while to crack, and once they do crack, we know how to fix them. Why would I worry about cracking them? I mean, what would you guys say to them as far as to try to get them on board with, you know, balanced mix design?
Well, I mean, if you live in a state where you don't have rutting or cracking, then I don't know if I would change anything as an agent.
Yeah, I mean, and that's kind of
I'm not out here trying to make people, you know, do balanced mix design. It's a tool that if your agency needs to focus on such an issue, then it's something that could be used. Now, I know Florida has a higher RAP threshold than we do. I know they use recycling agents, and we don't use those. So there could be some material things playing in there. I also know Florida builds on a much better base than we do over here. So and y'all have way more money than we do in terms of budget. So,
absolutely.
So there's a lot of things. Florida is a bad example to use, you know, for talking to someone from the.
You guys pick somebody else, please.
But there is one thing that I've learned from Tanya recently, that contractors in Florida have to guarantee a job for 3 years. Is that correct?
I believe so, yeah.
And so if that's the case, you want to put your best foot forward every day. That's the only thing I can say. I mean, contractors feel confident they don't need a balanced mix design. It has proven that it does improve mixes. So it's still a low bid world, I'm sure, there, like it is everywhere.
Exactly. Yep.
So, you know, now you've got a contractor trying to figure out, well, I need to have a little bit more performance in my mix design, so I don't have to go back and touch this job in the next 3 years.
Right.
Yeah. And it really, I think it also goes into if a state is looking to increase their recycled content or use innovative or biomaterials on a sustainability side, having a test that's able to screen out whether or not these materials are going to cause a detriment to the performance of the mixture is helpful, because we don't like to put down things that, you know, that we won't know how their performance is going to be for 10 years. That's an expensive trial, right, to do something like that.
Right.
But these laboratory tests, whichever are selected, are generally capable of at least identifying major changes in the mixture. So if you're looking at going to 50% RAP or 55% RAP, or a new recycling agent or a new type of binder, these tests are helpful in that sense.
All right, gentlemen. Well, we appreciate y'all being with us today, and I've enjoyed it. I've learned some things, and I'm going to turn it over to Molly real quick to close it up. And thank you again very much.
Thank you all very much.
Thank you.
I actually have one more question for you real quick. Has the department and or contractors needed to add technicians to keep up with the additional testing?
On the department side, no, we don't have any people in the plant currently. So maybe on the contractor side.
Well, we've also went through a change where, and I think Florida's already this way recently, where we don't have state inspectors present every day anymore. And so a lot of the work they used to do is now put on the contractors. But all I've seen mostly is contractors saying, you know what, guys, step up. So far, they're not spending money on adding a lot of people. Now, maybe some of your biggest contractors that are producing 3,000 to 4,000 tons a day, they may have another extra technician around now. But for the most part, no, we're not adding them. But we do have more. We've had more situations where a plant with 3 or 4 or 5 plants had a design lab with a design technician who manned that lab all year round, strictly doing mixed designs, and they dedicated their time to that as well, but did not add any extra personnel for that. It's real tough on a technician that's got to design his own mixes and run production QC every day as well. I hope that helps.
All right, thank you guys. We're at 3 o'clock or maybe a little after, so I have to end this since we're paying Sam and Barry by the minute here. Checks in the mail.
Might goes up after 3.
Yeah,
I'm gonna go check the mailbox now.
Be there. But thank you guys so much. This is a great conversation. I know we could talk for hours about what you guys are doing over there and how that relates to all of us in our respective states, or doesn't relate to us. But anyway, thank you all for tuning in remotely. And until we see you next year, have a very Merry Christmas and a Happy New Year, and let's get out of 2020. So thank you guys. Hope to see you soon in person.
Amen.
Bye.
Bye, guys.